I'm going to be solving FRQ number 12 that focuses on reactions. The first question asks to determine the products and write a balanced equation for the reaction, and the reaction contains excess nitric acid that is added to solid calcium carbonate. First, we'll start with our unbalanced reaction, which is right here. The reactants are right here. This is the nitric acid and the calcium carbonate, and then that gets us to these products. We check to see how much of each element is on each side. Some of them are already balanced, like the calcium and the carbon. Balancing H and an O won't be too hard because they're in the same compound when they're reactants, so you will only need to adjust the HNO3 on this side. So for H, we have 1 on the reactant side and 2 on the product side. So we would just need to multiply the reactant by 2 to get the same number as the product. Same goes for nitrogen. We have 1 on the reactant side and 2 on the product side. So again, we would just need to multiply it by 2 in order to get the two sides balanced. The oxygen is a little harder since we have 6 on the reactant side and 9 on the product side. But all we'd need to do to get it to be equivalent would be multiplying our HNO3 by 2, since that will give us 6 oxygens here and then 3 more from calcium carbonate, and that will give us the sum of 9, and it'll be equivalent on each side. So this is the final balanced reaction. The only thing that's changed is there's a 2 in front of the nitric acid, since we needed to double the amount of each one of these elements in order to have it be equal to the number on the product side. The second part of the first question is asking to briefly explain why statues made of marble or calcium carbonate displayed outdoors in urban areas are deteriorating. And the answer to this question is just that when calcium carbonate is exposed to acids in the environment, different substances can form. And these substances could turn out to be soluble or turn out to be gases. And a gas or a soluble substance will deteriorate much more easily than a solid. Then for the second question, that is asking to determine the products and write a balanced reaction again, but this time for a solution that contains silver 1 nitrate that is mixed with a solution containing iron 2 sulfate. And so this is the same as the first part of the first problem. So first we're going to write our unbalanced reaction, which is just AgNO3, or silver nitrate, plus FeSO4 will turn into Ag2SO4 plus FeNO3 So now that we have our full unbalanced reaction, we need to see how many of each element is on each side. And the elements that we need to balance are silver, nitrogen, and oxygen. So in order to get our 1 silver on the reactant side to equal our 2 silver on the product side, we'll just need to multiply the compound that contains silver by 2. And then same thing with nitrogen. We're trying to get our 1 nitrogen to 2 on the product side, and silver and nitrogen are in the same compound, so we will also just need to multiply nitrogen by 2. And then same thing goes for oxygen. It's in the same compound, so we're just going to need to multiply this whole compound by 2 in order for it to be balanced on each side. For oxygen, we start off with our 7 on the reactant side and our 10 on the product side. And we've got 3 oxygen in silver nitrate and 4 in iron sulfate. So down here, we're not doing anything to the iron sulfate, so we're just leaving that as 4, but we're multiplying the 3 that come from silver nitrate by 2 in order to get the sum of 10. So again, the only thing that's going to change in our balance reaction is we're just going to need to multiply the silver nitrate by 2. Then lastly, for part B of the second question, it's asking if the products of the reaction described above were filtered, which substance, if any, would remain on the filter paper. So this one's pretty easy because we already know that this is a precipitation reaction. Since there's a change in state between reactants and products, we've got 1 aqueous and 1 aqueous equals a solid and an aqueous. So there's our change in state, and this is going to be the precipitate. So then, like I said, only the precipitate will be left over since it's a solid, and everything else will get filtered through the paper except for the solid. So we just have silver sulfate left over.